grade. Today we're going to be doing Module 4, Lesson 18, and we're going to continue with our decimal multiplication. So as you'll probably see by looking at these numbers, the problems that we are going to be multiplying now are going to be going into bigger place values, and our answers are going to be changing up a bit. But all you need to remember is that rule from before where we just need to count our place values, and that is how many decimal places our answer needs to go into. So just keeping that in mind for today's lesson. Now, what we're going to start off with is we're going to kind of solve these problems similar to the way that we solved them in the previous lesson. So what I'm going to do is I'm going to take a look at this number, 3 2/10. And what I am going to do is I am just going to write this as a fraction first, just like I did with the previous lesson. So if I had 3 2/10, what I'm going to do is I'm going to pretend that that number doesn't have that decimal place there, so it looks like just the number 32. And that is going to be my numerator. And then I'm going to take a look at what is the last place value that it lands in. So if it lands in the tenths place, then I'm going to put a 10 underneath it. Now, what I'm going to do is I'm going to take a look at my next number. I have 2 1/10. Again, I'm going to take a look at this number without the decimal in it, so it looks like the number 21. So I'm going to put that in my numerator and put that all over. I look at the last place value that my number goes into, and that is the tenths place again, so I write 10 underneath. Now, what I would have to do to solve this problem is I would have to do 32 times 21, and then put that all over 10 times 10, which is 100. So before, when we were doing these problems, it was kind of easy for me to do this method because I could easily just do like the numbers on top, multiply them, and then make them back into a decimal. But this is a little bit tougher. 32 times 21 isn't a problem I can quickly do in my head. So what we're going to do instead is we're going to be doing a standard algorithm instead to help us solve these problems. You can still set it up like this with the fractions if that helps you out, but this way with the standard algorithm might be a little bit quicker. Now, normally if you were to set up this problem, you would see it as 3.2 over 2.1, and then we would multiply from there. But with these problems, just to help you understand what units you're multiplying, we're going to write these in unit form, and you're going to see this in your book as well. So it's going to say 32 tenths, just like we have right here, times 21 tenths. Remember, the last place value that your number lands in is the unit it has on back of it. So we're going to have basically 32 times 21, and then I'll show you what to do after that. So we know with our basic multiplication rules that we do this number. So 1 times 2, write that there, 2. 1 times 3 is 3. Then, since I'm moving on to this 2 right here, I need to add a 0. 2 times 2 is 4, and 2 times 3 is 6. Then we can start adding everything up, and then I get 2 plus 0, which is 2, 3 plus 4, which is 7, and 6 plus nothing, which is 6. So what this might look like is my answer is 672. But if we stop and think and I look at my numbers, if I have 3.2 times 2.1, probably wouldn't make sense for my answer to be 672. So that's where this part, my units, are very important, because just like before when I would multiply 32 times 21, I'm also going to think about, well, what is a tenth times tenth? And I know that a tenth times a tenth gives me a hundredth. So what I'll do is I'll bring down that unit right here. So I have 672 hundredths. Then what I need to think about is I still want my answer as a decimal. So in order to write this as a decimal, this unit form can really help me out right now. Because what that tells me is that this 2 should be in my hundredths place. Because remember, the units tell you what place this last number should be in. So if it's my units are hundredths, this means that the 2 needs to be in the hundredths place. Which then means that my 7 needs to be in the tenths. And then my decimal should be right here, but I still have this digit, so this 6 will be in my ones place. So that lets me know that my answer is 6 72 hundredths. Now remember from the previous lesson, I could also look at if I wanted to still do the standard algorithm but without the units, what I can still do is, if you were to solve this problem and it had the decimals in the numbers instead of the unit form, you could also do this problem basically exactly the same. The only thing to be careful with is that I know in some lessons our decimal would just go straight down, but in multiplying your decimal does not just go straight down. You'll notice that this decimal is over here. That's not because we got the answer wrong, it's just that there is 2 decimal places in this problem. So that means when I get my final answer, I have to move it 2 decimal places over. So, standard algorithm and the way that you see in your Eureka books are pretty much exactly the same. It's just helping you see what place value your answer should be in. So let's try this with the next problem. Our next problem has pretty similar digits. So for 1b, what we're going to do is 3 2/10 times 44 hundredths. And you may notice with this problem, we are now moving 1, 2, 3 place values over. So whatever our final answer is going to be, it's going to have to be in thousands. So I know that much at least. So what I can do is I can first think of these as fractions. So I can think of this as 32. I look at this number without the decimal. I think about what does this number look like. 32, what's the last place value? Well, the last place value is tenths. So I'm going to put a 10 right here. Then I multiply it by, I have 44 hundredths, but if I take a look at this number without this decimal, it kind of looks like just the number 44. And then I think about what place value is this last digit in. This place value is in the hundredths place, so I put 100 right there. And then I would solve. But remember, 32 times 44 is a little bit difficult. I can do 10 times 100 in my head. I know that that gives me 1,000. So just like we said before, my digits or my units should be thousands. I just don't know what my numerator is yet. And in this case, so I don't have to do 32 times 44 in my head, I'm going to set this up as a standard algorithm. So I have 32 tenths. And again, I'm just writing these in unit form because this is how you are going to see it in your books. And then I multiply it by 44 hundredths, like so. Then we can multiply. So I do 4 times 2, which is 8, and 4 times 3, which is 12. Then, since I'm moving on to this next place value, I have to add a 0. 4 times 2 is 8. And 4 times 3 is 12. Then I can add these two numbers together. So I get 8 plus 0, which is 8. 2 plus 8, which is 10. 1 plus 2 plus 1, or I could do 1 plus 1, which is 2. And 2 plus 2, which is 4. And then 1. So I know this looks like it's 1,408, but it's definitely not. If I have tenths times hundredths, because these also get multiplied too, tenths times hundredths gives me thousands. So what this tells me then is that my last place value needs to be in the thousandths place. So what I'm going to do is I'm going to write an 8 right here, my thousands. A 0 will then be in my hundredths. A 4 will be in my tenths. Then I need a decimal place. And then I have my number 1, which gives me my final answer of 1 and 408 thousandths. And that is our answer for this one. And then also, if I wanted to finish up this problem over here, I now know that 32 times 44 is 1,408. And again, over here, I'm showing you that I have 1,408 thousandths. And that's how I write that answer up there. So we're going to move on to the next problem. We're changing up our digits just a little bit, but the math is still exactly the same. All right. So for this next problem, we are doing 2 6/10 times 4/10. And just like before, we'll write this in our standard algorithm. We'll write this as fractions first and then our standard algorithm. So I'm going to take a look at this number. It looks like 26. So that will be my numerator. I take a look at the last place value that I see. The last place value I see in this number is tenths. So I'll write a 10 right underneath that. And then I'll multiply it by, over here, I see that I have a 4. Without the decimal, it still just looks like a 4. And the last place value is tenths. So I'll put 10 right there. Now, I could do 26 by 4 in my head, but that still could be difficult. So we're still going to do that standard algorithm. But I do know that my numerator, or my denominator, is going to be hundredths. And I see that I have 2 place values. So that means that my answer is going to be in the hundredths. So I'm going to set up that standard algorithm. So I have 26 tenths. So I'll make sure I write it in unit form just like that. And then I have 4 tenths. And I set it up just like that. And now I can multiply these two numbers together. So we do 4 times 6, which is 24. And then 4 times 2, which is 8. And 8 plus 2 gives me 10. So it looks like I have 104, but remember we had to multiply my units as well. So we have tenths times tenths, which gives me hundredths. And when I look at this number 104, another way I could think about it is that I need to have 2 digits in decimal places. So I'll go 1, 2, and I'll put my decimal there. So if that also helps you out, you can just count out your decimal places and then put your decimal in as well. And that might help you out if you're not super confident on where your different place values are at. So I have 104 hundredths, my 4 is in the hundredths place, 0 is in the tenths, and my 1 is in the ones place. All right, let's move on to our next 2 problems. And for these next 2 problems, if you want to try them on your own first and then watch how I solve, then you can do that as well. So we're going to be solving for 3 1/10 times 1 4/10. So if I were to write this as a fraction, I would have 31 tenths times 14 tenths. So it looks like I have 31 tenths times 14 tenths. I know that 10 times 10 is 100, and I see that I have 2 decimal places, so that means that my answer is going to be hundredths. And since I can't do 31 times 14 in my head, I'm going to set up a standard algorithm. So I have 31 tenths times 14 tenths. And now I can solve. So we have 1 times 4, which is 4. 4 times 3, which is 12. Add a 0 right here. 1 times 1 is 1. 1 times 3 is 3. And now I can add everything up. 4 plus 0 is 4. 2 plus 1 is, 2 plus 1 is 3. And 1 plus 3 is 4. So it looks like I have 434 as my answer. But remember, that is not our answer. So we have tenths times tenths still left over. 10 times 10 is hundredths. So I could do 2 ways to write my final answer. I could do like the way Mrs. Amir does it, where I say, okay, my 4 has to be my hundredths place. So 4 is in my hundredths, 3 is in my tenths, which means I have a decimal right here, and my other 4 is in the ones. Or you can kind of, you could rewrite this 434 and count over how many decimal places you're supposed to have. So I know I need 1, 2 decimal places, so I'm going to count out 1, 2, and then put that decimal right there. And again, we get that same answer of 4 and 34 hundredths. All right, and on to our very last problem. And you'll notice that this last problem is almost exactly like the problem we just solved. It's just that our place values are a little bit different. So think about, what is that going to do to the value of our answer? So we have 0.31 times, or 31 hundredths times 1 4/10. And if I count out my place values real fast, I'll see that I have 1, 2, 3. So that means that my answer is going to be in the thousandths place. So again, I rewrite this number in fractions. So I have 31 hundredths times 14 tenths. And then I know that I have 100 times 10, so that's going to give me thousandths. So that lets me know that my answer is going to be in the thousandths place. I can't really do 31 times 14, so I'm going to set up a standard algorithm. So I have 31 hundredths, and then I have 14 tenths. And remember, if you want to try and solve this problem on your own, so you could pause me and then replay when you're ready to see the answer. So we have 1 times 4, which is 4, 3 times 4, which is 12. Add a 0 here because we're moving on to this next place value. 1 times 1 is 1. 1 times 3 is 3. Add everything up like we did before. And again, I get 434. But remember, my value is definitely going to change because I still have these hundredths times tenths, and that's going to give me thousandths. And remember, 2 ways to write out your final answer is I could think about, okay, well, this 4 needs to be in the thousandths. This 3 will be in my hundredths. This 4 would then be in the tenths, which means my decimal will go right there. I can even add a 0, and I get a final answer of 434 thousandths. Or I could rewrite this number, 434, and count out my place values. So I know I need 1, 2, 3 decimal places. So I count out 1, 2, 3, and then put my decimal, and I could add my 0 as well. And I still get that same answer of 434 thousandths. If you need any help before you move on to the U-chart problem, please make sure you ask for help. And you're going to be solving for 42 tenths times 12 hundredths. So you should try to write it out as a fraction because you are going to see that in your Learn and Succeed books. So I would just kind of get some practice with it and get used to it. And then you'll also need to write out the standard algorithm and show me your final answer in decimal form. So go ahead and try this, and then once you're done, you can move on to the problem set. Good job today, and good luck.